Imagine this. One ordinary night in 2017, astronomers scanning the skies spot something that doesn't belong. It's not from our neighborhood. It's not even from our solar system. This thing blasted in from the endless black between the stars, zipped past our sun at breakneck speed, and then accelerated away like it had somewhere better to be. No tail, no glowing halo, just a weird, tumbling shape that refused to play by the rules of physics we thought we understood. That object was Oumuamua, the first confirmed interstellar visitor humanity has ever detected. And it didn't just visit. It shattered our comfortable little bubble about how alone we are in the cosmos. Fast forward to 2025, and guess what? It's happening again. Another cosmic wanderer is barreling toward our sun. And this time, we're watching it come in real time. But here's the twist that keeps me up at night. These aren't just rocks or ice chunks. They're messengers from worlds we may never visit, forcing us to rethink everything from how planets form to whether we're truly the only ones looking back across the void. Today, we're diving deep into the mystery of Oumuamua and its interstellar siblings. I'll break down what we know, what still baffles the experts, and why these encounters might be rewriting the story of our place in the universe. Stick around until the end, because I'll share a real-life parallel that hits closer to home than you expect, and a powerful takeaway that could shift how you see the night sky forever. If you're even a little curious about space, aliens, or just the sheer weirdness of existence, hit that like button and let's explore the unknown together. Let's rewind to that pivotal moment in 2017. Astronomers at the Pan-STARRS telescope in Hawaii caught a faint blip moving unusually fast. At first, they assumed it was just another comet or asteroid from our own backyard, the Oort cloud or the asteroid belt. But as data poured in, the anomalies stacked up like puzzle pieces that refused to fit. This object didn't follow the gentle, elliptical orbits everything in our solar system obeys, bound by the sun's gravitational embrace. Instead, it screamed in on a hyperbolic path straight from interstellar space, slingshot around the sun, and rocketed back out at over 87 kilometers per second. That's more than twice the speed needed to escape Earth's gravity from our orbit. For context, our fastest spacecraft, like the Parker Solar Probe, it tops out around 200 kilometers per second near the sun with massive engineering help. Oumuamua did it naturally, like it was born for the void. What really blew minds was its behavior near the sun. Gravity should have tugged it, slowed its outbound leg. But observations showed it speeding up instead, an extra push with no visible explanation. No dust, no gas jets, nothing. In my view, this isn't just a quirky anomaly. It's a wake-up call. It challenges the neat categories we've built: asteroid versus comet, natural versus something else. Physicists like Avi Loeb have speculated openly about artificial origins, not because they're chasing little green men, but because the data demands we consider all possibilities. If it were a natural object, why the perfect non-gravitational acceleration without the usual cometary fireworks? Diving deeper into the physics, let's talk trajectories. Objects born in our solar system loop in closed ellipses or parabolas. Interstellar ones like Oumuamua enter on open hyperbolas. They're just passing through, borrowing the sun's gravity for a quick course correction before vanishing into the galaxy's currents. Oumuamua came from the direction of the constellation Lyra, roughly toward the star Vega. Vega isn't special in a sci-fi way. It's a young, hot star, but it was our North Star 14,000 years ago, guiding ancient navigators. Coincidence? Maybe. But it adds a poetic layer, a visitor from the direction that once anchored our ancestors' sense of up in the sky. The shape only amplified the strangeness. From reflected sunlight, it appeared highly reflective, brighter than typical dark space rocks, and its brightness pulsed every 7 hours or so. Not a steady glow like a spinning potato-shaped asteroid. This suggested extreme elongation, a cigar-like form. Perhaps 100 to 800 meters long, but only 35 to 167 meters wide, tumbling end over end. Or a flat, pancake-like disk. Either way, nothing like the lumpy boulders we're used to. As someone who's followed astronomy for years, this flips my perspective on space rocks. We've cataloged thousands of near-Earth objects, but Oumuamua felt alive in its defiance. It wasn't passive debris. It interacted with the sun in ways that mimicked propulsion. Natural explanations exist. Perhaps a hydrogen iceberg or nitrogen ice shard from a shattered exoplanet. But they stretch plausibility too. The lack of visible outgassing while still accelerating. That's the detail that lingers. It forces us to ask, what if advanced civilizations send probes that use subtle, low-signature tech? Or what if natural processes in other systems produce objects far weirder than our models predict? To make this tangible, let's ground it in stories that feel real. Picture a team of astronomers in Hawaii, bleary-eyed from all-night observations in 2017. One researcher, spotting the initial data, thinks it's a routine find. Then the velocity numbers hit. Hyperbolic. Panic, excitement, frantic calls to colleagues worldwide. Telescopes from Chile to Hawaii pivot urgently. For weeks, every spare minute of observing time goes to this fleeting guest. It's like hosting a surprise diplomat from another country. You scramble to learn their language before they leave. A more personal parallel. I remember as a kid in the 90s, staring at Comet Hale-Bopp through binoculars with my family. That bright tail, the fuzzy coma, it was magical, a clear visitor we could all understand. Oumuamua offered none of that comfort. No tail to point at and say, see, ice melting. Just a silent, accelerating point of light that vanished too soon. It left scientists with regrets. Proposals for intercept missions died because the object had too much of a head start. One idea involved a gravity-assist slingshot past Jupiter, then the Sun. But timing made it impossible. That what if haunts the community. What secrets did we miss because we weren't ready? Now, fast forward to 2019 and our second visitor, 2I/Borisov. Discovered by an amateur astronomer in Crimea, this one was unambiguously a comet complete with the dusty tail and gas halo we'd expect. It originated from a similar northern sky direction, but behaved normally, made of familiar ices. Yet its arrival so soon after Oumuamua felt like the universe saying, "You saw one, here's another to compare." In just 2 years, we went from 0 known interstellar objects in centuries of watching to 2. Statistically, that suggests these wanderers are more common than we thought, perhaps thousands drifting through the galaxy at any time, like cosmic pollen. Enter 2025's newcomer, 3I/Atlas, spotted early by an automated survey system while still far out, beyond Jupiter. This beast is massive nucleus, potentially 10+ kilometers across, with a coma making it even larger. It's barreling in from the galactic, thick disk, a region of ancient stars where things could be billions of years old, predating our solar system. Unlike the head-on meetings with the first 2, Atlas is approaching sideways, set for a grand tour. Close passes by Mars, Venus, and Jupiter, but conveniently, or suspiciously, missing Earth while we hide behind the sun during key moments. Here's a vivid example from real astronomy history that mirrors this. Think of the Voyager probes. Launched in 1977, They used planetary gravity assists to tour the outer planets before escaping into interstellar space. They're still sending data decades later, and our own messengers now beyond the heliopause. Imagine if an alien equivalent of Voyager zipped through our system. Would we recognize it? Or dismiss it as weird debris? Atlas gives us time to watch, perhaps even redirect a Mars orbiter or the Juno spacecraft for a closer look. That possibility excites me. Real hardware already in place, ready for an impromptu rendezvous. It's like having a neighbor's security camera catch a stranger walking by. We might finally get high-res data instead of blurry glimpses. Stepping back, these objects aren't just scientific curiosities. They're profound. Oumuamua's possible nitrogen ice origin. Imagine a chunk blasted off a Pluto-like world in another system highlights how destructive collisions shape the cosmos. A rogue impact shatters a dwarf planet, ejects frozen nitrogen, invisible when sublimating, highly reflective. And the sun's gravity flings the shard our way. No visible tail, but plenty of invisible thrust. Elegant, natural. Yet it mimics what we'd expect from a lightweight probe with hidden propulsion. But let's add my analysis. Even if natural, the implications are huge for panspermia. The idea that life or its building blocks hitch rides on interstellar debris. A 7-billion-year-old comet from the thick disk could carry ancient organics or even dormant microbes. We've found complex molecules in our own comets. Scale that across galaxies, and the universe becomes a vast exchange network. Or consider the great filter in Fermi paradox discussions. Maybe intelligent life is rare because most civilizations never spot these visitors in time to learn from them. The timing feels almost orchestrated. After millennia of empty skies, 3 in quick succession, it suggests our solar system is drifting through a denser patch of galactic traffic. Our sun orbits the Milky Way's center every 230 million years. Perhaps we're crossing an ancient stellar stream rich in ejected material. This reframes humanity not as isolated on our pale blue dot, but as participants in a dynamic, interconnected galactic ecosystem. Critically, the alien probe hypothesis, while fun for late-night debates, remains speculative. No signals, no course corrections toward Earth, just a flyby. Yet dismissing it entirely ignores how our biases limit inquiry. And history shows paradigm shifts. Plate tectonics, microbes causing disease, once crazy, now foundational. Oumuamua reminds us science thrives on open-minded rigor, not knee-jerk skepticism or wild claims. Another relatable story. In 1908, the Tunguska event flattened Siberian forests, likely an air-bursting asteroid. Locals described it as a second sun. Fast forward, and modern surveys like ATLAS, the same system that found 3I/Atlas, now catch potential impactors early. These interstellar visitors add another layer of risk and wonder. What if one carried not just ice, but technology or biology? Unlikely, but the possibility enriches our vigilance. On a human scale, think of immigrants or explorers arriving in new lands. Oumuamua was the scout brief, enigmatic, gone before we could fully engage. Borisov, the familiar traveler. Atlas, the massive elder, touring slowly. Each teaches us about resilience, objects surviving eons in the radiation-blasted void, only to briefly warm by our star. As we continue monitoring 3I/Atlas through 2025, watching its coma grow, its path refine, we stand on the cusp of real answers. Will it reveal more anomalies, offer clues to other solar systems' chemistry, or simply remind us how much we don't know? The clear lesson here is this: the universe is far stranger, more connected, and more alive with possibility than our daily routines suggest. Oumuamua didn't just change our view of space, it changed our view of humility. We are not the center. We're a brief waypoint for cosmic travelers. Embrace that wonder. Look up on clear nights. Support astronomy, whether through citizen science apps, backing missions, or simply sharing these stories. Because the next visitor might bring knowledge that transforms humanity. Or it might already be here, waiting for us to notice. What do you think Oumuamua really was? Drop your theories in the comments. If this expanded your cosmic perspective, subscribe for more deep dives into the unknown. Thanks for watching. Keep questioning, keep exploring. The stars are calling.